So let's look at the difference between theoretical and experimental probability. Theoretical probability is going to be that number of times an event can occur divided by the total number of outcomes. Experimental is going to be what actually occurs when we collect that data. So there are going to be similarities and differences. It should actually eventually fit that theoretical, but the issue is sometimes the experimental does not match. So let's start with just rolling a six-sided die. I could sit and I could roll a die, and let's say I want to look at the probability of rolling a 2. Now there's 6 different outcomes that I have, so the probability should be 1 in 6. So if I roll a 1, so I've rolled 5 times so far. So if that probability fits, maybe I should have a 2 on my next roll. I got another 1, 4, and we've noticed that now with 10 different, I've actually had 0 times occur. That doesn't mean it's changed what the probability would be. It's still 1 in 6, but it's the difference between this theoretical probability of being 1 in 6 and the experimental turning out to be 0 out of 10. Now, that doesn't mean the probability is 0. It's just in this experiment, maybe I haven't done enough. So what I can actually do is, what if I had 10 different die? So I could roll these and see what I have. So now looking at this, I again have 0 out of 10. There's 2 out of 10. There's another 2 out of 10. And now there's 3 out of 10. So now that I've done it quite a few times, I've actually done 50 different attempts. I have 7 out of 50, which comes out to be about 0.14. Now, this was 1/6, which is about 0.167. So we could actually see they are getting closer and closer together. And maybe after having a large set of numbers, it does get closer and closer to this. So just because an experiment doesn't quite work in the beginning, and actually it looked like it was miserably going to fail with 0 out of 20 for the first ones, in the end, as these numbers get bigger and bigger, that law of large numbers is going to get us closer to it. Now, let's take another scenario. What if I was going to look at rolling an even? Now, if we look at our sample space, there's actually 3 different possibilities. So the probability is 3 out of 6 or 1/2. Now, let's just roll a couple of them at a time. 5 and a 3, 2 and a 5, and then a 2 and a 1. Now, if I look at this experiment that I did, I actually have 4 out of 10 by my experiment, so 2/5. So my experiment actually turned out to be less than the theoretical. It doesn't change the theoretical, but it's still now 2/5 in the difference. So now look, what if I did the probability of rolling a greater than 1? So looking at my sample space, greater than 1 would be all of those. So there's actually 5 different options, so it's 5 out of 6. So we're going to get real quick. We're going to roll all 10 and find our greater than 1. So I got a 1 here, and the rest work. So this was 9 out of 10. Do it again. We have no 1, 10 out of 10. We have 2, so that's 8 out of 10. 10 out of 10. Oops, we got 1 there, so that's actually 9. And this one is 7 out of 10. So I got 43 out of 50 in my experiment. Let's see how close that turns out to be. 43 out of 50 is 0.86, and 5/6 is about 0.83. So they actually got closer and closer. When if I just went off 10, then I had 90 versus 0.83, but it got closer as I went. Now let's change it and say, what if we roll 2 dice and look at the sum? Now we actually have a table we can draw here with all of our options. So 1 dice and the second dice, we have all these sums, and so we can fill it in. Now 1 and 1 is 2. I can keep working my way through, and we get to all of our possible values. So our sample space is any of these we have here. We actually have 36 different outcomes, but the sums, I could get 2, 3, 4, all the way up to 12, and notice there's different amounts of them. So let's first look at the probability that I got doubles. So probability of doubles. So I have to look on here at all the ways I could get a double. So really I could have 1 plus 1, 2 plus 2, 3 plus 3, and on down to 6. So there's actually 6 ways out of 36 possibilities that I could get doubles, which is 1/6. Now I'm not going to roll too many of them, but we can start to see if we did an experiment. We'd have 1, 2, 3, 4. On the 5th one, so I have no, 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 yes, I got a double, so we'll do one more. There's another no. So really on those 6, I got a 1 out of 6. That was the doubles. Another no. No. And there's a yes on our number 10. So we actually had here really 1 out of 6 or 2 out of 10 was our experimental probability. So it actually came up a little bit more in our experiment than the theoretical. Okay, what if we did the probability that if I rolled a sum of, not 10, let's go sum of 7. So we look at all the occurrences that it happens here. And there are 6 occurrences. So that is also 1/6. And so I can sit and roll here again and get a probability. What if I did the probability of a sum greater than 9? So now I look at all of my possible values and how many ways it could occur. Now I know I have 36 because there's 36 different outcomes. So the ones greater than 9 would be this set here, which is 6. So we'd have 1/6. And I realize now that all of my examples have now given the same probability of 1/6. Let's just throw one in that won't be 1/6. How about the probability it's even? An even sum. So we can count all the occurrences. We have 1, 2, 3, 4, and 18 different occurrences. So we get 18 out of 36, which turns out to be 1/2. So there's a 1/2 probability that I would roll an even sum. So now let's move on to some coins and flipping coins. Now I know if I flip a coin, I could get either heads or tails. And so if I looked at the probability of heads, it's 1 out of 2 occurrences. And I could sit and I could flip a single coin over and over again and say, and see what I would get. And even though I may get a large, like here, of heads, eventually, if I have a large enough number of events, it should get close to 1/2. Now right here, I have 4 heads out of 5, so it's 4/5, which is a lot more than 1/2. But right now, if I flip this coin again, there's no different probability of 1/2 it occurring, even if there's been a lot of heads. Still 1/2 for each event. But right now, for that experiment that I did, I happen to get 4/5. Let's look if I flipped multiple coins. So let's say I had 3 coins, and I wanted to look at the probability that all 3 are heads. So let's draw out how that occurs. So I have a first coin, and I can either get heads or tails. And from the second coin, I get heads or tails. And then the third coin. So I could actually write out all of the options that I have. So my sample space is heads, 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 tails. It's going here. Then I go heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, and all tails. So this is my sample space. These are all the options that I could get. I actually have 8 different outcomes. So the probability of getting all heads is 1 out of that 8. Now what if we wanted to look at something different? Maybe the probability that I get 2 heads. This one, this one, this one. So there's actually 3 cases where I would get 2 heads. So that would be 3 out of 8. Maybe we want to look at the probability that I would get at least 2 heads. So that's taking 2 heads and also taking into account that we have 3 heads. So I'd have 1, 2, 3, 4 different options. So that would be a 1/2 probability. So then we could also do the experiment from that and flip these coins and notice what I get. So here I got 2 heads and a tails. Again. So I finished my 8, and here are my 8 events in my experimental probability. So let's look to see if we matched them. So up here I said the probability that I get all heads is 1/8. So in my experiment, I didn't get any that were all heads. So the probability of all heads in my experiment turned out to be 0 out of 8. Probability of 2 heads. So I had 1, 2, so that was 2 out of 8, which was close compared to 3 out of 8. We're one event off. And the probability that I got at least 2 heads, I had 1, 2, and it looks like I got real tails happy here at the end, so that turned out to only be 2 out of 8. The theoretical needs to be what you can calculate. In the experiment, it may be close, it may be off, but it's trying it and finding where your probabilities turn out.